Okay, I think I'm going to show you all the calculator coolness using this example here, because it does say using NCR to expand the binomial, and we're going to expand this big one here using a calculator to complete the binomial coefficients. Now, again, I might ask you just for the coefficients at times. I may ask you to do everything, okay? The expansion, okay? But let's see. I mean, to actually expand this, you know what it's asking, right? It's asking you to do this. Whoa! Okay, now I know what you're thinking. Which row should I look at? What's number 5? So you should be looking at row 6. That means how many terms? Let's write everything that you know. 6 terms you should have, right? It's 6th row of Pascal's triangle. You know what? I'm going to write P's triangle, okay? Because you may forget what PT is. Pascal's triangle, right? 6th row. Like little things that we should keep in mind, okay? Now, we're going to use the binomial theorem, but also just for the actual coefficients, here's what you can do with the calculator, okay? Be ready for your mind to be blown, okay? Now, in your calculator, you're going to put this, NCR, and you're going to put parentheses, but I'm going to show you on the calculator after I show you this really quick. 5, why? Because that's the exponent, and you're going to put curly brackets, 0, 1, 2, 3, 4, and then 5. Okay, wait. If you're unsure of why are we putting this, it's the 0th term, 1st, 2nd, 3rd, 4th, and 5th term. How many terms is that total? 6 terms. 6 terms, okay? Make sure you read this, okay? Make sure you slow down if you have to digest anything. Now, wait. We're looking at the 6th row of the Pascal's triangle, so we're looking for 6 terms. This is the 6 terms that we're looking for. If you go to the 6th row of the Pascal's triangle, you get this, right? So hopefully on our calculator, we do get that. And I'm going to prove to you that we do using the calculator. So it'll help you, but also expanding too. Okay, so wait for it. Hello, chakbang ng moy, chakbang ng moy. Okay, now let's actually input that into our calculator. So how to use NCR and factorial. Yeah, okay, like earlier we did 10, choose 3, right? Miss Chang has 10. She's going to choose 3 students. Here's what we do. We go to menu, and you just go to probability, because that's kind of like what we're doing. This is not probability. No. Okay, lots of students like mistaken it that way. It's an accounting principle, actually. It's not probability, okay? We're going to go to combinations. Oh, yeah, let's do factorial first. How about that? Oh, no, not the answer, silly. We're going to go, what? 10 factorial. What? Let's do 10 factorial divided by, what did we have earlier? 7, okay? Times 3, okay? And you remember how we got 120 different ways that Miss Chang could choose 3 students to go to dinner with her out of 10? 120. That's right. Okay, that's actually a formula for NCR. We do probability again. And we have factorial. We have permutations, we'll do later, and combinations, which is NCR. I have N, I choose R. I have 10, I choose you. Okay, now let's go 10, 3, just to suffice the answer here. Exactly. The formula works. It's N divided by N minus R times R. Okay, now let's do the one where the example 1 where we had to expand and we're looking for the coefficients right now. We do the same thing, NCR. So menu, probability, NCR, and you know what we press? We press the actual exponent, and then we press curly brackets if you want to just do the coefficients, okay? 0, 1, 2, 3, 4, oops, sorry, 4, 5, okay? Ready? Dun, 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 dun. What should it give us? 1, 5, 10, 10, 5, 1. Those are the values in the 6th row of the Pascal's triangle, okay? All right, I think if you know all this, then you're good to go to finish the expansion. The expansion is super easy. I'll do one example, and then you'll be on your own for the rest of the class. Maybe you won't even need the rest of the videos. I don't know, okay? Slow motion. I almost fell over, okay? Wait, so when we did this in the calculator, what did we get? We got 1. Oh, sorry, I'm not even writing. 1, 5, 10, 10, 5, 1. These are the coefficients. So wait a minute. What does that tell us about the binomial expansion of a plus b? Okay, to the 5th power. What does that mean? Well, we know we're going to have 6 terms, right? So we're going to do this. Okay, this is really tricky. We know our answer is going to be 1, right? 1, 5. You need a lot of space. 10, 10, 5, 1. These are the coefficients, right? Now, what about the A's and B's, right? A, B, A, B. I'm just going to write A, B, and we're going to fill in the coefficient. Fill in the expansion. Fill in the exponents, okay? So with the purple or the blue, I'll write that. Wait, remember A decreases. So it's going to be a 5, 0. Because 5 plus 0 is 5. It should always equal 5. Dun, 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 dun. 4, 3, 2, 1, 0. And then B is going to increase. 1, 2, 3, 4, 5. Check your addition. 5, 5, 5, 5. Dun, 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 dun. And then you know what? It's always going to be, just for now, let's put a plus here. Okay? Because of course that could change based on this guy here and whatever the quantity is. Okay, so be careful with that. So the answer is going to become, let's simplify. It becomes a to the 5th plus 5a 4th b plus 10a cubed b squared plus 10a squared b cubed plus 5ab4 plus a sub 0 is gone, so we're just left with b5. Okay? All right, so that's our expansion. I know nobody in this room really wanted to go ahead and multiply this out. That's a lot of work, okay? Some of you guys, a plus b times a plus b is a lot of work. Okay, now one more thing. I want to apply the binomial theorem with NCR. I don't know if you remember the NCR, okay? It's in the next section here. You can see here, dun, 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 dun. But I'll talk about it without going over the theorem per se, okay? So actually these 5, this 1, 5, 10, 10, 5, 1, can it be achieved by NCR? Dun, 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 dun. How do I do that? All I do is this. This is n choose, well, we'll just start with whatever we have. The n is how many you have. You have 5. 5 choose 0, okay? And then you go A5, B0. You see how this guy and this guy both show up here and here, okay? And we're going to do the next one. Plus 5 choose 1, A, B. Let's just write the actual coefficients first. 5 choose 2, A, B. Plus 5 choose 0. How far do we go? That's probably what I'm hearing from you. You go until 5 choose 5. Oh, sorry. This is going to run a little bit to the end here of the paper. So I'm going to actually go like this and push it back a little bit. Dun, 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 dun. Relax time. Relax time. I'm going to cut this sucker out. Okay. I'm going to move this guy a little bit to the side here. Don't worry about that circle there. Okay. Sorry. Okay. So I'm going to start writing plus. Oh, sorry. I need that space. So I'm going to erase that. Plus 5 choose 5. You go until 5 choose 5. Okay. And then you know what we should do with that? We should actually write the A's and fill in the A's and B's with the exponents. And it's easy because you just follow what's in here. The n choose R. The n choose R, okay? You ready for this? So you go, remember, the A decreases, right? And then the B increases. It follows exactly what the R is. Ooh, so many patterns. If you're really strong with patterns, you're really in luck. If the other sections have been difficult for you and you're good at patterns, then you're really, really super duper lucky this unit. So wait, so I'm going to write this out pretty. 5 choose 0, A5, and B is gone. Plus 5 choose 1, A4, B1. Plus 5 choose 2, A3, B2. Plus 5 choose 3, A2, B3. Plus 5 choose 4, A1, B4. Plus 5 choose 5 and just B5. Just B5 because these go away, right? These go away. I'm going to highlight the ones that are going away. This guy goes away and this guy goes away because A to the 0 is 1. Now, if I expand this like this using the binomial theorem per se, guess what it actually ends up being? This is actually 1. This is actually 5. 5 choose, wait, you know what? If you want to think about it, think about it. If I have 5, how many ways can I choose 1? I could only choose one way. All of my 5. Think about that. We're going to talk about that more and more in class, okay? So I'm going to put a 1 here. Plus 5 choose 2 is 10. A cubed B2. Using the formula, of course. A2 B3. And then 5 A1 B4. And dun, 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 dun. 5 choose 5? Wait. In how many ways? Wait, sorry. Okay, so this one here, 5 choose 1. That means if I have 5 people I'm choosing from, how many ways can I choose 1? I could choose person A, B, C, or D. That's why it's 5. Oh, D, E, or E. 5. That's why there's one way. There's only 5. There's 5 ways. Okay. How about here? Now, this one is always kind of tricky, so we're going to talk about that in class. But 5, choose 5. How many ways can I choose all 5? Just 1. So that's why it's 1. And that's why this is B5. Okay. Now, I'll provide the transcript for these notes, but try a few on your own. And what I explained here is actually just below these. Don't be scared so much about these notations, okay? All right. Good luck. Bye.